Welcome to this wonderful pH and pOH screencast on a lesson that I did earlier. So here's what we're going to go ahead and do in this screencast. First, we're going to go ahead and define what pH and pOH is. And then we're going to do some sample problems. And finally, we're going to have some homework help for your problems 1, 6, 10, and 18 from your book. And finally, we're going to go ahead and review everything we learned for the day. So first, what is pH? pH is a quick and easy way to define what the concentration of hydrogen ions is. Rather than saying there is a concentration of 1 times 10 to the negative 4th hydrogen ions present, we can simply say that pH is 4. It's much simpler. If something has a pH of less than 7, it is acidic. And if something has a pH of more than 7, it's basic. And if it has a pH of 7, it's neutral. So you might be asking, well, what's pOH? Well, pOH is pH's brother. It measures the concentration of hydroxide anions present in the solution. And just like with pH, it is a simplified way of stating the concentration of hydroxide anions present. So why you might be asking, why is it pH over pOH when we use it in society? Well, one day a bunch of chemists decided to use pH instead of pOH while enjoying a nice cup of coffee. Or simply stated, no one really knows. Needless to say, pH is the accepted scale, but pOH is something that you do need to worry about. But right now, don't worry too much about it, just know how to calculate it.
Alright, let's go ahead and flash back to that magic trick that I did earlier in class. And we're going to go ahead and calculate the pOH of the flour. And to do that, you're going to first have to know what the OH negative concentration, the hydroxide anion concentration. And I'm going to go ahead and give that to you. And that's 1 times 10 to the negative 12th molar hydroxide concentration. And so using that concentration of hydroxide anions, we're going to go ahead and use the equation pOH equals negative log concentration of hydroxide anions to find out what the pOH. And so plugging that into the equation, we're going to get pOH equals negative log of 1 times 10 to the negative 12th. And when you plug that in, you're going to go ahead and get pOH equals 12. Right now you're probably going, well, Mr. Donaldson, I want to know what the pH is. I want to know what the pH before the flour was sprayed. How do I find that out? Well, using a very simple equation, which is the equilibrium constant of water, you can determine what the hydrogen ion concentration is. And using the equation Kw equals hydrogen ion concentration times the hydroxide anion concentration equals 1 times 10 to the negative 14th. And plugging in what we already know, we can go the hydrogen ion concentration times the hydroxide anion concentration, which was 1 times 10 to the negative 12th, equals 1 times 10 to the negative 14th. And we're going to go ahead and get the answer to be 1 times 10 to the negative 2nd. So now we can determine what the pH is. And the way we do that is using the same equation as the pOH, but instead of the hydroxide anion concentration, we're going to go ahead and use the hydrogen ion concentration. And so that equation is going to look like pH equals the negative log of the hydrogen ion concentration. And when we plug in the numbers that we know, you're going to get the pH equals negative log of 1 times 10 to the negative 2nd. And when we plug that in, we're going to go and get the answer to be pH equals 2. So now using all that knowledge that you just gained, it is time for you to determine what the pH is of the flour after getting sprayed. Now I'm going to go ahead and help you out through this process. So first I'm going to go ahead and give you the hydroxide anion concentration, the OH negative, and that is 1 times 10 to the negative 4th. And using that, let's go ahead and calculate what the pOH is. Alright, so now using that number that you were just given, let's calculate the pOH. Do you remember what the equation was? I'll give you a second to figure it out. Are you stuck? Don't worry. The equation is pOH equals negative log of the hydroxide anion concentration. And if you don't remember what the number was, it's going to be pOH equals negative log of 1 times 10 to the negative 4th. Go ahead and calculate that and let's see if you got it right. Did you get a pOH of 4? If you did, good job. If you didn't, go ahead and look through what you did got. So now using that pOH number, let's go ahead and calculate what the pH is. Do you remember how to do that? Well, first let's go ahead and have you walk through the steps. What do we do first? Well, first, we're going to go ahead and find out what the hydrogen ion concentration is. If you remember how to do that? I'll give you a second to figure it out. If you don't remember, here's the equation that you're going to use. You're going to use the equilibrium constant of water, which is the hydrogen ion concentration times the hydroxide anion concentration equals 1 times 10 to the negative 14. You're going to go ahead and plug and chug, and you should get an answer that looks a little something like this. From there, you're going to go to here, and finally, you should get an answer that looks like 1 times 10 to the negative 10. And so let's go ahead and use that hydrogen ion concentration that you just calculated to find out what the pH is. Do you remember how to do that? I'll give you a second to figure it out. Here's a hint. You're going to use the equation pH equals negative log of the hydrogen ion concentration. And for those that don't remember what the number is, it was 1 times 10 to the negative second. Did you get a pH of 10? If you did, good job. Have you determined what the pH and the pOH of the flour was before and after getting sprayed with the ammonia? But what if I told you there was a shortcut for figuring out what pH and pOH is? If you know pH or pOH, you can find the other using a very simple equation. The equation was pH plus pOH equals 14. So let's go ahead and use the example of knowing what the pOH was, and let's say it was 4. We can now determine what the pH is without having to go through the equilibrium of water, using that equation. And so, using that equation, you're going to find out that pH equals 10. Whoa, much quicker, right? Now that you're a master at determining what the pH and the pOH is of certain objects and substances, let's go ahead and do some homework help. The way the book is set up is the problems I'm going to go ahead and go over are going to help you figure out some other problems in the book. Not every single problem will be gone over, again, because the problems that I go over will help you with those ones. And so let's go ahead and start with number 1. Number 1 asks you to find the pH of a 0.001 molar solution of hydrochloric acid. So what do? Are we going to use the pOH equation or the pH? If you said we're going to use the pH concentration, you are correct. And what we're going to go ahead and do is plug in this number right here to determine the pH equals 3. At this point, let's hope that you've been through 1 through 5. The reason being is those ones were relatively easy. Now we make things a little more difficult. Let's start with number 6. Number 6 asks you to find the pH of a solution containing 1 mole of hydrochloric acid in 12 liters of water. First step, we're going to find the molarity. We're going to do 1 mole of hydrochloric acid over 12 liters of water. We get the answer to be 0.083 molar solution of hydrochloric acid. Now we find the pH. To do that, we use the equation pH equals negative log of hydrogen ion concentration. We plug in our molarity, 0.083 molar hydrochloric acid. We get a pH of 1.08. Let's hope you've reached number 10. And number 10 is a little more difficult because it's going to ask you to do a little bit more work. Number 10 asks you to find the pH of a solution containing 0.005 grams of hydrochloric acid and 120 milliliters of water. So first, you need to find how many moles of hydrochloric acid. I'm going to go ahead and let you do that since you know how to find grams to moles. If you're stuck, here's a little hint. You're going to multiply 0.005 grams of hydrochloric acid times your molar conversion of 1 mole of hydrochloric acid over 36.453 grams of hydrochloric acid to get 1.37 times 10 to the negative 4th moles of hydrochloric acid. So now that you know the moles of hydrochloric acid, it's time to determine what the molarity is. Do you remember how to do that? If you don't, you know the moles of hydrochloric acid over liters of water. So you're going to go ahead and go 1.37 times 10 to the negative 4th moles of hydrochloric acid over 0.12 liters of water. Notice how I converted 120 milliliters of water to 0.12 liters. You're going to get an answer of 1.14 times 10 to the negative 3rd molar hydrochloric acid. Then, using your molarity, you can determine what the pH is. again, plugging in our equation, pH equals negative log of the hydrogen ion concentration, which is the molarity of our solution, you're going to get an answer of 2.94 pH. Come to number 18. Number 18 is a bit of a doozy. It's a hard one because it's asking you to do a lot. But if you break it down into simple steps, it's actually a lot easier than it looks. So let's go ahead and look at it. Number 18 asks you to find the pH of a solution containing 6.7 grams of nitric acid and 4.5 grams of hydrochloric acid in 8,000 milliliters of water. It's a lot of information. So let's break it down into steps. The first thing we're going to do is find the moles of hydrochloric acid and nitric acid. I'm going to go ahead and let you do that since you know how to find that answer. I'll give you a minute. So if you're a little stuck, here's a little help for the hydrochloric acid. You're going to multiply 4.5 grams of hydrochloric acid using your molar conversion of 1 mole of hydrochloric acid over 36.453 grams of hydrochloric acid. You're going to get 0.123 moles of hydrochloric acid. Now for the nitric acid, you're going to use 6.7 grams of nitric acid times your molar conversion of 1 mole of nitric acid over 63 grams of nitric acid. You're going to get 0.106 moles of nitric acid. Let's go ahead and flash back to some of our previous problems. What were we really trying to determine? Was it the moles of the acid or the moles of hydrogen ions? If you answered the moles of hydrogen ions, you're correct. So using some of that knowledge, let's go ahead and figure out what we're trying to do. What we're going to try to do is figure out the moles of the hydrogen ions in this solution that we're creating. And so using what we know from the moles of the prior problem, or the prior step, what we're going to do is we're going to add the moles of nitric acid and hydrochloric acid together to get the moles of the hydrogen ions. Again, let me repeat that. We're going to add the moles of nitric acid and hydrochloric acid together to get the moles of the hydrogen ions present in the solution. You should get an answer of 0.229 moles of hydrogen ions. Essentially, that's the number of moles of the combined acids in this solution. So now using the moles of the hydrogen ions, we can determine what the pH is. First, we're going to find what the molarity is. You're going to use the numbers 0.229 moles of hydrogen ions, which we just determined, divided by 8 liters of water to get 0.029 molar hydrogen ion concentration. I'd like to point out that I went from 8,000 milliliters to 8 liters to find this equation. Then we can find what the pH is. Again, using the equation pH equals negative log of hydrogen ions, we can determine what the pH is, and that is 1.54. Now that we've done all of our homework problems, let's quickly review what we just learned. pH is a simple scale to determine how many hydrogen ions are present in solution. Saying a solution has a pH of 4 is a whole lot easier than saying there are 1 times 10 to the negative 4th hydrogen ions present in a solution. Next, pOH is just like pH, but instead it measures the concentration of hydroxide anions present in a solution. So now let's review how to determine the pH. To find pH or pOH, you must first know the concentration of hydrogen ions or hydroxide anions present in solution. If you know the concentration of hydrogen ions or hydroxide anions, you can determine the other by using the equilibrium of water, and that is Kw equals the concentration of hydroxide anions times the concentration of hydrogen ions equals 1 times 10 to the negative 14th. And now if you want to find the pH, you can use the equation pH equals negative log of the concentration of hydrogen ions, or you can find the pOH using the equation pOH equals negative log of the concentration of hydroxide anions. If you know pOH or pOH, you can determine the other by using the simple equation pH plus pOH equals 14. Now, something that's always helped me in my college career and can help you for the rest of your life probably is the key to success and the fewest amount of headaches is remember to break each question down into simpler steps. Doing this will help you out significantly and make things a whole lot easier. And finally, to wrap this all up, remember, all of these equations can only be used for strong acids and bases. Let me repeat that. All of these equations can only be used for strong acids and bases. You will learn about how to calculate the pH and pOH of weak acids and bases at another time. And that wraps up our lesson on how to calculate the pH and pOH of solutions. If you need any further help, please resort to your book or ask Mr. Ash for any further questions.